The topic of this problem is operational amplifier circuits, and the problem is to determine Vout and Iout in the circuit shown below. So we have a circuit that has one voltage source in it. It has a 5-volt source, and Iout is measured as the current in the bottom leg of our circuit in this configuration. Vout is the voltage measured at the output of our op-amp. So to solve this circuit, we're going to use the properties of an ideal op-amp. First of all, we have the symbol for an ideal op-amp, which has two inputs, an inverting input and a non-inverting input. Each one of those inputs has a voltage and a current associated with it. We know that the ideal op-amp has these properties. First of all, the currents into the op-amp are equal to 0. There's no current flowing into the input of an ideal op-amp. And that the voltages at the inputs are equal. V minus is equal to V plus. So these are the properties that we're going to use to solve our circuit that is given in this problem. So the first thing we're going to use is this first property of the circuit, that there's no current flowing into the ideal op-amp. So if there's no current flowing into this non-inverting input of the op-amp, that means that Iout is a current which is confined to this loop that we have at the bottom of our circuit. So if we want to find Iout, we can use Kirchhoff's voltage law to do that. And we can use Kirchhoff's voltage law around that mesh. And in this case, Iout is measured in a counterclockwise direction. So we're going to sum our voltages up counterclockwise around this circuit. So if we start at the bottom right-hand corner and start around the circuit, we first encounter the negative polarity of the minus 5-volt source. So it's minus 5 volts. And then we have the voltage drop across a 20 kilo ohm resistor, which is 20K times I out, plus the voltage drop across the 10K as we continue around this loop. And the voltage across the 10K is going to be 10K times I out. And then we return back to the starting point. And so we know through Kirchhoff's voltage law that the sum of those voltages is equal to 0. So if we use that equation and we solve for I out, then we end up with an I out which is equal to 1/6 milliamps. Now that we know I out, we can go back and perhaps find V out. And the way we're going to do that is using the second property of the ideal op-amp. If we know what the voltage is at the non-inverting input, it's going to be equal to the voltage at the inverting input. So can we find the voltage at the non-inverting input, which is the voltage at this point in our lower loop? It's going to be equal to 10K times I out. So the voltage at the non-inverting input is equal to 10 kilo ohms times I out, and I out is 1/6 milliamp. So our voltage at the non-inverting input is equal to 10/6 of a volt. We also know that that is equal to the voltage at the inverting input. So the voltage at this node at the non-inverting input, at the inverting input, has a voltage level of 10/6 volts. Then we can use Kirchhoff's current law at that node. Let's call it node 1. And we're going to sum the currents into that node in order to find an equation which has V out as the unknown. So let's sum the currents into that node. We have the current through the 10 kilo ohm resistor flowing from left to right. It's going to be 0 volts minus the voltage here, which is 10/6 volts, divided by 10K. 0 minus 10/6 divided by 10K. We also have the current which is flowing from right to left through the 20 kilo ohm resistor. It's going to be V out minus 10/6 volts divided by 20K. So that's the current flowing right to left into node 1 through the 20 kilo ohm resistor. And we also have the current which is flowing out of the inverting input of the op amp, we know that that is equal to 0. We're going to add it in for completeness. And that's all of our currents that are summing into node 1. So this is an equation which just has V out as the unknown. It's the only unknown in the equation. So we can solve for V out. And if we do, we end up with a V out equal to 5 volts. So now we have I out, which we've been looking for, and also V out.